This course is LTE FDD ANR Feature Guide. In this course, we will introduce ANR feature and the basic principle. Later, we will introduce the key parameters and how to configure this function. So ANR, this function is automatic neighbor relation. It's one of some feature. So for the ANR, it aims to reduce the workload of manual neighbor relation configuration. During the handover procedure, we know if we miss configuring a neighbor cell, it will generate the handover failure. So in order to guarantee the handover success rate, we should guarantee the neighbor relation. So the ANR function, it can automatically configure the missing neighbor. The ANR functions, it involves intra-write, intra-frequency ANR, intra-write, inter-frequency ANR, inter-write ANR. It includes the following sub-functions. One is neighbor self-addition and self-deletion, fast ANR, LTE to LTE, the intra-write, low handover success rate processing, removal of neighbor cell relations for continuous handover failure, removal of neighbor cell relations that have no handover within a long period, redundant neighbor removal, and the ANR timing processing. Later, we will introduce the ANR subfunctions one by one. Let's see the overall technical principle. The ANR function actually is located in the inode side. The OMC just sets the ANR function strategy, but how to add the neighbor relation and delete the neighbor relation is realized by the inode side. In the sense of measurement concept, the neighbor relation table, it includes neighbor detection function and neighbor removal function. So the inode side, it will maintain the NRT, it will maintain the table. This table, it will consider when to detect and add the neighbor and when to remove a neighbor. So the neighbor detect function, it will find a new neighbor relation and add it to the NRT. The neighbor removal function deletes a neighbor relation that meets the deletion conditions from the NRT. So let's see this picture. The O&M, that is the OMC, it will deliver the strategy to the inode B side. The inode B side, it will maintain the NRT, this table. This NRT table, it includes two parts. One is the neighbor relation, one is the neighbor relation attributes. The neighbor relation is, it has the different 1, 2, 3. Every neighbor relation, it will map to one target cell ID. Different neighbor relation, it may have different neighbor relation attributes. For example, in this table, the neighbor relation 1, the target cell is 1. In this target cell, it can not remove from this table. And here, the no handover and the no X2 handover, there is no marks, that means it's okay. For the neighbor relation 2, the table 2, the TCI, the target cell ID is 2. But here the no handover, no X2 handover, it have a mark. That means in this neighbor relation, it's forbidden to perform the X2 handover like this. So it defines the neighbor relation and also defines neighbor attributes. So when the neighbor function, the neighbor removal function or the neighbor detect function, it detects a neighbor meet the strategy, it will report to the NRT measurement function. It will perform the NR update. So this is the basic principle. So the whole NR procedure, it relays the EMS, it relays the inode B side and relates to the UE side. So EMS, is used to make strategy. Inode B used to perform the measurement. UE used to perform the neighbor detection. So in this procedure, we first need to create the ANR policy. So the ANR policy is delivered to the inode B side. It will deliver to the inode B side. So when the inode B side receives an unknown PCI, so the UE it will report a new cell PCI. This new cell PCI is not exist in the inode B neighbor relation cells. So it thinks this is an unknown PCI. So when the inode B receives the unknown PCI, it will select a UE to detect the unknown PCI cell CGI information. So when we select the UE will read the cell system broadcast information to get the specified PCI. And later UE will report it to the sewing cell. It will report the MR. In the MR, it contains the PCI and also contains the SRP information. So the inode B, it will, based on the strategy, it will report the neighbor cell information to the EMS to request the EMS to add the neighbor cells as a formal neighbor cells. So the neighbor cells during the ANR procedure, it contains two kinds. One is temporary neighbor cells. Another is formal neighbor cells. The initial procedure, does the inode B get the neighbor cells and add it to the NRT? At this condition, this is just a temporary neighbor cell. When it reports to the EMS will add it to formal neighbor cells table. So this is the ANR procedure. So how the inode B select a UE? It's not randomly select. Actually, it's based on the UE capability. We know during the attach procedure, the UE will report its capability to the network. So the network will know whether the UE supports the ANR feature or not. So when the inode B select a UE perform the unknown PCI, CGI information detection, it will consider the UE capability. So we have the requirement to UE capability. So let's see the detailed basic principles. We know in the ANR, there is one basic, is the intra-write ANR function. That is, in the LTE system, if we want to add the LTE neighbor cells, this cell is the intra-write cell. So this function it depends on how the cell broadcasts its ECGI in the network. In LTE system, the cell global identification is the ECGI. So it will map to the PCI. When the UE mirrors intra-write neighbor cells in accordance with the measurement configuration delivered by the inode B side, it will report the measurement result to the inode B. So this measurement report, it will include the PCI of the target cell. So if we just know the PCI, we cannot get the real information. The real cell information is the ECGI because the PCI can be reused, ECGI cannot. So the inode B side, it will send a command to the UE to detect the ECGI. So the second step is the inode B. It will command the UE to use the found PCI to read the ECGI of the new neighbor cell. That's we said the cell B. And except the ECGI, it also will detect the tag, the available PLN ID. To achieve this goal, the inode B selects an appropriate UE to detect the ECGI. The UE should be at connected state, and usually, in order to avoid the effect of the service, usually select the UE, just no important service. For example, there is no voltage. And during this procedure, how the UE could read the ECGI? So in LTE system, the SIP1 system information, it will contain the basic information of the cell. So the UE will read the target cell SIP1 to get the target information. So after reading the ECGI of cell B, the UE will report the detected ECGI, the detected tag, and the PL1 ID to the. So usually, it's not the UE reports the ECGI. Later, the node B added to the neighbor cell directly. We will consider whether this cell should add it to the neighbor relation table. So we will usually use the handover successful rate to evaluate it. So we will set a statistical period. During the statistical period, if the number of the successful handovers is not zero, and the statistical results meets the algorithm mentioned, the node B will request the EMS to add the temporary neighbor cell as a formal neighbor cell. So usually it cannot meet the strategy we set, so maybe it will delete it. This is the intra-write ANR principle. So in this procedure, the UE mirrors the intra-write neighbor cells in accordance with the measurement configuration delivered by the node before and send a MR to the node B. The measurement report, for example, here the report, it reports the strong signal of the PCI is 5. So when the cell, here we consider the serving cell is the cell A. The serving cell PCI is PCI 3 and ECGI is 17. The cell, it will compare the report PCI to the neighboring relations. If the PCI file is unknown, so it will command the UE to use the found PCI file to read this cell ECGI. For example, we call this target cell is cell B. It will read the cell B's ECGI tag and PLMN. So during this procedure, the node B will select improper UE to detect ECGI. So when the UE gets this command, it will read the target PCI file cell B, to read the BCCH to get the SIP1 information, achieve the ECGI and the target tag and PLMN ID, this information, and report to the cell A. And the cell A could add it to the temporary neighbor cells. This is the basic principle of the intra-write. So for intra-write ANR principle is similar to the intra-write. Thus, the intra-write, this neighbor cell is 2G or 3G. The intra-write is LTE itself. This measurement frequency should be configured on the node B. So if the cell A, this is our serving cell. If this cell in the node B is have already configured the ANR function, in connected mode, the node B will select the UE with a measurement capability in cell A to mirror the intra-write neighbor cells. And later, the UE will report the detected cell PCI in a target system of frequency to the node B. For U-turn cell, the PCI consists of a carrier frequency and a primary scrambling code. It's different with LTE. For GSM cell, the PCI consists of BCC, NCC, and BCCH RFCM. The init bit commands the UE to use the find PCI to read the related information of the inter-right neighbor cell. For the 3G cell, for a Utron cell, the UE needs to read CGI, log, and ROG. For GSM cell, the UE should read CGI and log. So after reading the related information of new neighbor cells, the UE sends the detected information to the init bit. So the whole procedure are similar with the inter-write. So this picture shows the basic procedures. The serving cell, it will set the ANR function and set the status. It will let the UE to report neighbor request commands, and later the UE find a neighbor cell. It will report to the serving cell A, and the serving cell A finds this PCI is unknown. It will select the UE to report the target information, and the UE will perform the target cell information detection and later report to the cell A. Here we should notice that the UE report the unknown PCI may be different with the UE detect target cell B information. It may be same, may be different. So during the intra-site, the intra-LT or inter-LTE, the intra-system or inter-system ANR function, when we consider add or delete the neighbor cells, we should perform the cell filtering algorithm. That is, in the table, no matter the temporal table or the formal table, the neighbor cells, the number is limited. We cannot always add neighbor cells unlimitedly. So during this procedure, it will perform the cell filtering. We only consider the strongest and the fastest neighbor cell, add it to the serving cell. So as we see this picture, it shows how it's sorting the cells. The addition and deletion of the ANR neighbor cells are controlled by the maximum number of neighbor cells and the handover success rate of the neighbor cells. It will ranking the neighbor cells by handover success rate. Every time the ANR statistical period ends, the init will filter the neighbor cells in the statistical range according to the handover success rate. The init it selects the temporary neighbor cells whose handover success rates are higher than or equal to handover success rate threshold of the neighbor cells. So here, temporary neighbor cell 1 or temporary cell 2, temporary cell 3, temporary cell 4. These cells, it will filtered by the handover success rate and will rank it again. So based on the handover success rate, ranking down. The selected temporary neighbor cells and the formal neighbor cells are sorted according to the numbers of successful handover. We usually set a threshold number. For example, this number is n. So if n is smaller than the neighbor cells, the maximum number of neighbor cells, the temporal number cells, and the formal neighbor cells, it will determine. The neighbor cell deletion process is originated for the n formal neighbor cells. The neighbor cell deletion process is originated for the n temporary neighbor cells. So it detects if the n or n formal neighbor cells or temporal neighbor cells is full, so it will ranking down. When it exceeds the maximum number, it will based on the ranking to perform the detection and perform the deletion procedure. so it always keeps the maximum number. Every time the ANR statistical period ends, in node B filters the temporary neighbor cells in the statistical range according to the handover success rate, and in node B selects the temporary neighbor cells whose handover success rates are higher than or equal to the handover success rate threshold of the neighbor cells. Compared with the normal ANR, we have another is the fast ANR. When fast ANR is enabled, the node B will deliver the report strongest cells environment in advance so that the UE can detect the PCI of the strongest neighbor cell before it arrives at the cell edge. So the neighbor cell detection process is complete in advance. For normal ANR, the node B determines whether the PCI reported by the UE belongs to an unknown neighbor cell only after receiving the event, the handover environment report event A3 or A5 like this, and then starts the CGI environment of the unknown neighbor cell. So the fast ANR, it performs the environment and report more faster than normal ANR. So we call it fast ANR. So fast ANR for intrafrequency neighbor cells is different with the interfrequency neighbor cells. For the intrafrequency neighbor cells, when a UE access or is handed over to a cell, the error interface environment is reconfigured for the first time. That is, when the UE access to a cell, it will configure the environment information. If the fast ANR function is enabled, the report strongest cells environment will also deliver the environment PCI of the neighbor cell with strongest intrafrequency SRP. For interfrequency, when the UE receives A2 event, the report strongest cells environment will be delivered from environment PCI of the neighbor cell with the strongest interfrequency SRP. So for the mutual neighbor cell configuration on the EMS level, after receiving a request of adding a formal neighbor cell from an element, the EMS determines whether to add a two-way neighbor cell relation accordance with the mutual neighbor cell configuration switch. So this we call it mutual neighbor cell configuration. So usually the neighbor relation is dual direction. So if we detect one-way neighbor cell relations, this is ANR function. It only detects one way. In order to improve the neighbor detection efficiency, it can consider the mutual neighbor cell configuration. So it can be performed from two levels. One is configure on EMS level. Before we introduced. So for the mutual neighbor cell configuration on the EMS level, after receiving a request for adding of formal neighbor cells from the network element, the EMS determines whether to add a two-way neighbor cell relation in accordance with this switch. If the switch belongs to neighbor cell is turned on, the EMS checks whether it's necessary to perform mutual neighbor cell configuration. Otherwise, the EMS does not perform mutual neighbor cell configuration. Another is on the node B level. So the node B level, it has one process, that is, the node B needs to configure the X2 interface. So the local node B obtains configuration information of outgoing cells and the neighbor cells of an adjacent node B by interacting with the X2 interface. So it knows whether the adjacent node B configures it as a neighbor cell. If the local node B is configured as a neighbor cell of the adjacent node B, but the local node B did not configure the adjacent cell as a neighbor cell, so the local node B will perform the two-way cell addition process. The inode B ANR function have another is if we detect the neighbor cell with low handover success rate, we can delete it. So the ANR function, it always detects the handover results of all the neighbor cells periodically. So it includes the temporary neighbor cells. For the neighbor cells with low handover success rate, we can set the default processing policy. That is, whether the handover is allowed, maybe it's not essential. So once a neighbor cell with a low handover success rate is detected, we can perform the following process. One is that we can mirror the ECGI to detect whether the PCI confusion occurs in the neighbor cell. Second is determines whether the neighbor cell is a temporary neighbor cell or a formal neighbor cell. If it's a temporary neighbor cell, the no handover property of the cell is such. If it's a formal neighbor cell, the cell it will delete it directly. A third is that the notably reports the temporary neighbor cells with low handover success rates to the list, which can be queried in the EMS to require manual processing. Here it has a no handover property of the cell. That is, we can set in the temporary neighbor cells, we can set a blacklist. During the ANR procedure, if we find the temporary neighbor cell handover success rate is too low, we will move this temporary neighbor cell to the blacklist, and it will forbidden the handover procedure. During a period, it will go back. So this is how to process the low handover success rate neighbor relations. Except that the ANR it also can detect and delete the neighbor cell relations that have no handover for a long period. If the neighbor cells during a long period there is no handover happened, we consider it's not an essential neighbor cell, so we can delete it directly. And we also can delete the neighbor cell relations for continuous handover failure. If we detect the continuous handover failure between the serving cell and the neighbor relation also can be deleted. So once the neighbor cell is redetected by the UE during the measurement, the ECGI measurement is reperformed for the PCI of the neighbor cell. So the neighbor cell is re-added according to the measurement result. So in this way, the UE can be prevented from performing handover to the neighbor cell that has incorrect information, and the impact on the cell handover success rate can be reduced. Also, the ANR function, it can detect the redundant neighbor cell and remove it. A redundant neighbor cell, it refers to an external neighbor record that is not configured as a neighbor cell of any cell of the local inode B in the external neighbor configuration. So, for this function, the redundant neighbor cells of the inode B, it will be detected periodically, and the statistics are performed separately in terms of the system mode. For each detection period, the total number of redundant neighbor cells removed of all the modes cannot be more than 128. For neighbor cell configuration, the ANR it supports the auto-update. During ANR procedure, if the neighbor cell information reported by UE measurement or obtained from X2 interaction is not consistent with that configured on EMS, it will update the neighbor cell configuration on EMS. So that is the basic principles. As we see the parameters and the configuration. During the sum procedure, we have the sum policy configuration. In the configuration, we have the sum measurement. So when we click the sum measurement, it will show the sum measurement information like this page. So when we set the sum policy, we will find the sum policy measurement and set the sum policy. So when we click it, it will show the FDD and TDD product policy configuration list. And we can select, for example, we select FDD. So it will show FDD policy. We can click the different policies. And also in this procedure, it will have the sum policy overview information. So in the FDD sum control, pop up the FDD sum control interface, we can set the service type. The service type, we can set the ANR, and the service switch, we set it open. So we open this sum ANR function. This function is enabled. We should set the detailed strategy and set this function to the target in node B. So we can click the new sum control and then click the set on the toolbar. The set page, it will display. Set the node B on which the sum control is take effect and click OK. After the ANR enable switch is sent to the node B successfully, so it will display in the result column. So this is first enable the ANR switch. And later we set the detect ANR policy. So we double click the FDD ANR policy. The FDD ANR policy tab, it will display in this red pane. So here is the red pane. It shows the ANR policy template created through the EMR command. So in this ANR policy, it includes the common configure, intra-LTE, inter-system DRAM, inter-system U-turn, these parameters. We will configure one by one. The common configuration, it will use for all the dedicated configurations. For intra-LTE, inter-system, they will use the basic information. After that, if we configure the intra-LTE ANR, no matter the intra-frequency or inter-frequency, we should configure the intra-LTE. For the inter-write DRAM, you should configure the inter-system DRAM parameters. For the inter-write U-turn, you should configure the inter-system U-turn parameters. So here it shows the common parameters. In these parameters, for example, you should set the run mode. The run mode it indicates the operation mode of the policy. It has two kinds. One is free mode. The free mode means the ANR optimization will execute automatically. Another mode is the controlled mode. Controlled mode means ANR optimization will execute under control. So the operator could decide to confirm or reject the procedure. Usually we set it free mode. The whole procedure can be executed automatically. If we set it controlled mode, we should configure the ANR reference point policy. That is, we have many different reference points. The different policy, different reference points, it will report the monitoring. And if there is a breakpoint, the breakpoint timeout length and the breakpoint timeout policy setting, it will based on the controlled mode. The ANR mirror object choice counter. This parameter, it indicates when an unknown neighbor cell is detected, the node B will select some UE to mirror the neighbor cell CGI. So this parameter, it indicates the maximum number of allowed measurements for each detected neighbor cells. For example, we set here the default value is none. That means for this detected neighbor cell, the maximum number of allowed measurements is none. If after none is failed, we will don't use this one. The maximum number of UEs execute ECGI measurement. In the intra-LTE system, it will perform the ECGI measurement. This parameter indicates the maximum number of UEs chosen in each ECGI measurement. That is, once one UE reports the unknown PCI, the inode B only could receive this number UE to perform the ECGI measurement. Here the default is 1, which means it only selects one UE to perform it. So this is the basic parameters. For example, it has the timer length of ANR temporary neighbor cell statistic. That is, we know the temporary neighbor cells, it will set a statistical timer. So this is used for cell filtering algorithm. And the maximum number of neighbor cells added once. So we find different unknown cells and we detect the ECGI. So how many neighbor cells once we could add it? This is the maximum number. If the number exceeds this value, it will delete some neighbor relations with the less handover success number. So this is the basic parameters. After the common configuration, if we configure the intra-LTE, we will configure the intra-LTE parameters. In the intra-LTE ANR configuration, so here it will have a LTE PCI SRP threshold. That is, when the UE detects unknown PCI, at which condition it will perform the ECGI measurement. So the SRP here is -105, which means if we detect unknown PCI SRP greater than -105, we will consider perform the ECGI measurement. It decides which condition we could perform the ECGI measurement. And the neighbor cell report threshold. When an ANR temporary cell is added, the inode B will set a statistical timer to count MR times and handover success times. After this timer timeout, if the MR times less than this value, if it reports MR times less than this value, then the temporary neighbor cell cannot be added to the formal neighbor cell list. So the handover success rate, so when the temporary cell is added, inode B will start just like we said, MR times and handover success times. Last parameter is decide the MR. Here is decide the success rate. So if the handover success rate is less than this value, it cannot add it to the formal neighbor cells. And for the intra-LTE centralized neighbor cell relation bidirectional configuration switch, this is before we introduce this bidirectional configuration detection. So if this one we set it, we open it, so it will detect it's one-way neighbor cell or two-way neighbor cell. So the rest parameters, it decides at which condition it will add it to the neighbor list. For example, here, the handover success rate threshold for intra-frequency neighbor cell addition, 98%. That means the handover success rate threshold for intra-frequency here, only the neighbor cell handover success rate here or equal to this one, it can be added to the neighbor cell list. So this parameter is a basic, and this parameter we can consider is advanced. It should meet both parameters. So for these parameters is controlled when we can add a cell to the temporary neighbor cells, and when we can report it to the formal neighbor cells. This is intra-LT neighbor cell relation. If we configure the fast ANR feature, so for the fast ANR feature, it will open the fast ANR period switch. The fast ANR switch is used to control open for fast ANR feature of the node B. So this switch is configured as global switch. And for this, it's both used for intra-frequency and inter-frequency ANR switch. Its name is switch of periodic ANR. If we open it, the network will perform the fast ANR. When the UE access to the network or hand over to a new cell, the network will deliver the measurement configuration of report strongest cell, so it can use the fast ANR. In the intra-LTE, it will configure the low handover success rate and the long period no handover detection. So this is the parameters for the handover success rate parameters. The switch of low handover success rate detection. If we close this switch, all these parameters is invalid. It will not detect low handover success rate. When we open the switch, it will detect during the statistical period. If we find some neighbor cells handover success rate lower than this threshold, we will delete this cell. So here it defines the period of the detection is 24 hours. Here usually the default unit is hour. So in 24 hours, it will perform the statistical. And the handover time threshold is 50, which means during this procedure, if the handover time is less than 50 times and the handover success rate lower than 24, we consider this is a low threshold. This is a low threshold. So this procedure it will performed controlled by these parameters. And for the long period, no handover detection is also controlled by the switch and the parameter. So the switch of long period no handover detection is closed. It will not perform this detection. If we open it, it will detect. During the period of long period no handover detection here, if found the threshold of handover less than this value, we can consider is no handover detection. We will consider delete it. So it includes many different parameters to support the different sub-functions. For the redundant neighbor cell deletion is configured at the common configuration. There is one parameter is redundant neighbor cell deletion period. This period is very long. The unit is days. The default value is 15 days. That means it will detect it during this critical time. If it opens this switch, it will detect it. If it finds the cell is a redundant cell, it will delete it. If the ANR policy parameter templates need to be associated to the node B, which the ANR policy is to take effect, we will select the node B to be associated. And If this parameter is need associated to the target cell, we also can associate a target cell. We can set the inode B also can set the target cells. So that is the configuration. So we only introduce the